Hello friends, welcome back to the bench. Our patient today is this beautiful Pyle, what is the PTA42BT, supposedly 500 watts. It is possible. It's 4-channel amplifier, so we can connect 8 speakers, and each channel has its own volume knob. We have 2 microphone inputs, obviously Bluetooth and FM radio, but this one has built-in FM antenna, telescopic. Very nice device. I love these Pyle devices. They rarely break, and when they do break, they are usually easy to repair. So let's pull up the ticket, and I have a PTA42BT amplifier that I was given that has no output on all channels. It powers on, relays click, FM radio searches for and locks onto known radio frequencies. I opened the case and checked power supply voltages. They were close to what I expected, so problem appears to be in the audio circuit. I am unable to trace, blah blah blah, with no schematics. Obviously you're not going to find schematics for these, or you're not going to find schematics for when you look for Pyle model and schematics, but if you know what to look for, you will find schematics for this exact amplifier. Pyle uses very common amplifier circuits. And the whole device is built from like pretty much pre-made blocks, right? So we have a Bluetooth module as a separate, separate board. We have a card reader and USB reader as a separate device. So sometimes you can just pinpoint the fault by disconnecting circuits. In this case, we are facing output stage issues. So when I received the ticket, I didn't even check, because I should have probably Googled the model and see what it is, because I was expecting that this is going to be one of these with 25 to 45 watt output stage, which is integrated into one chip on a big sink and a heat sink, and those fail because the maximum supply voltage is 25 volts, while they're being controlled or supplied with 26.5, 27, even 28. I already made a video on these, and the best solution is to just replace the output stage. It's about 20-25 bucks in Mauser or DigiKey, and the one you replace it with is the one that accepts 35 volts instead of 25, and that resolves the problem and also gives you a little bit more power. These ones, on the other hand, are different. So as you can see, we have transistors and the bridge rectifier on the heatsink. There's no active cooling on the heatsink, and the ventilation, yeah, that's Pyle, right? The ventilation is at the bottom. The top ventilation is technically there, but I guess we don't want any dust inside for whatever reason. For that reason, we're gonna block some heat with this. That's typical for Pyle devices. They're often not thought through very well. We have 8 transistors for 8 outputs, 4 outputs stereo, so 4 times 2, which means each transistor is responsible for each output, and we have big resistors, power resistors, and two more transistors per output, which means that this is class AB amplifier, which means that it's gonna be heating up. We're gonna check it out under the thermal camera to see what's getting hot, and this is probably what's gonna reveal the problem. Whatever is shorted here will immediately register on the thermal camera as soon as we turn it on. The clicking doesn't have to mean anything, meaning these relays will click open, right? They will close the circuit as soon as you turn on the amplifier. Then the power starts circulating, basically going onto the speaker, and if that is too much, or the voltage is too high, or there's short, anything like that, that will cause the relay to open again, to open the circuit, to basically cut off power. So the clicking would be there whether the output stage is working or not. Either way, you're gonna hear clicking. So that clicking sound doesn't really tell us much. It is kind of weird because we have 4 outputs and only 2 relays. Usually, because relay can handle, depending on the relay, but one relay can handle 1 channel at the most. Sometimes you need 2 relays per channel, depending on the relay, obviously. Which means that I would expect 4 relays here, and we have only 2. So that would mean, on one hand, I was thinking that 2 channels are bridged together. So this is 2 output device, but AB and CD are bridged together. But if that was the case, we wouldn't have a separate volume control for each channel. So they must be separate. And we can actually confirm that really quickly, because if they are bridged, then we're gonna read short between these two. Yeah. These two, yeah, nothing. So yeah, they're definitely not bridged. So that's curious. Maybe those relays are handling 2 channels at the same time. Interesting. Or maybe only red outputs are going through the relay and black outputs are not. It's possible, because once the circuit is opened, it doesn't really matter which side. I mean, it matters a little bit because we're talking about inductive loads, right, which are speakers. Okay, so first thing that we gotta do is turn it on, see what it does, see the thermal image, what's getting hot, and go from there. Okay, I'm not connecting it through the light bulb because we have a transformer. So, and actually, since the customer already turned it on and confirmed that it's working, but the output stage is not working, which is very common, because even if you just completely disconnect the output stage from this, it'll still work. Because as I said, this is modular structure over here. Many things can be disconnected and they will work independently. For the same reason, if you have access to these parts, suppose you have the broken one with the output stage completely fried, like literally the board fried up. I've had one of these. Then you can just replace the boards respectively, you know, any board on this device, which is very nice. We have nice protection on the wires. This is something that a lot of Pyle devices are missing, right? This little sleeve, so the cables don't touch the heatsink. Well, here we actually don't. So the cables, the input voltage cables coming from the transformer are touching the heatsink. I mean, we can I can probably position them so they don't touch. All right, now let's turn it on. Let's hit recording here, and there's nothing hot. Oh, that's the reflection here on the heatsink. So let's turn it on and see what's gonna get hot. First thing getting hot are these two resistors. That's normal. Okay, so one last time. We have preamps here heating up to about 40 degrees, 47 below 50. Another preamp. Those two resistors over here, that's normal. And this line of transistors, so the lower ones, are heating up. That is normal. Our main transistors are not heating up yet because we don't have the load connected. And you know, in this case, they even shouldn't heat up if there is no load, or if it doesn't work. I know that they're not going to be heating up. And here we have a big resistors again, and only one of them is heating up. But that is absolutely normal on Pyle devices. And corresponding voltage regulator is at 70 degrees. Yeah, that might be our issue, but that's typical for Pyle devices to have no heat sinks on the linear regulators. That's something you have to accept with Pyle. Yeah, 76, that is a bit high. I would definitely put a heatsink on it. But that's normal. It's all normal. Oh, and here we have preamps over there. These are operational amplifiers used as the preamplifiers. They will be getting hot. That is completely normal. So let's see what we can do. So first thing that I want to confirm is whether we're getting any output signal. Meaning, we're going to connect a dummy load, which is going to be 4 ohm resistor, like this. We're going to connect it to the output, and we're going to inject a 1 kilohertz sine wave. Then, very important for the scope, this is something that I missed when talking about this oscilloscope, that you have AC and DC coupling. Right? In this case, we're going to use AC coupling, and I actually mentioned that it doesn't have AC coupling, and it did. Someone corrected me in the comments. I mentioned that you can connect it through the capacitor, which, you know, for the DC signal, capacitor is an open circuit, right? And for the DC signal, for the AC signal, it is a wire, right? And obviously depending on the frequency and all that. But for AC signals, capacitor conducts. For DC signals, capacitor is an open circuit. It'll just charge and never discharge. Now, let's connect us to speaker A. Okay, we're connected to the speaker A. right? And so on the Pyle devices, we just, it's set to auxiliary. The output auxiliary, we have auxiliary 1, 2, and the FM slash Bluetooth slash whatever. So hit mode, and it switches to Bluetooth. Find it on your phone. Oh, this is weird. Okay, it's telling me that there is only 10% battery left, which means we have a tiny issue with a Bluetooth board. We'll see if we can figure out, because the Bluetooth is registering as battery low. The Bluetooth module has an ability to do that. It just detects the input voltage, and in this case, since it's not battery operated, it's not battery powered, there's probably a voltage divider that gives us say 3.5 volts, which should be around 3.4, 3.5, and that is considered fully charged battery. But our divider probably ends up delivering maybe 2.5 volts, which is considered low battery. Okay, now let's get the signal generator. So with Bluetooth devices, this is awesome because you don't have to connect anything to generate signals. Right, about the AC coupling. And normally what I do is I connect the oscilloscope to the battery, in which case I don't care about whether the coupling is AC or DC. In this case, I'm connected to the power supply, which means I have to be in the AC coupling. Otherwise, I'm going to be pulling the black output of the amplifier to the ground. That's going to immediately cause heating. It's not good for the amplifier. It will work, but it's not good for the amplifier. Okay, let's start the generator, and indeed we don't have anything on the output. Oh, we do have. Okay, because it was turned down. So we do have something, but we have clipping. Why do we have clipping? Right, only half the phase is transmitted. So this is the issue with it. So the signal is transmitted to the output, but at a very low amplitude, and it's clipped at the top. So 1/2 of the amplifier is working. But is it really? Let me connect it properly. Yeah, okay, that was my bad. Yeah, the amplitude is low. So this is maximum volume, and our RMS is 995 millivolts at 1 kilohertz. So we're transmitting a frequency correctly. The shape is correct, but we have no power. That's why it sounds like there's no what do you call it? There's nothing coming from the output because you just can't hear it. So before we confirm that every channel is suffering from this, let's make sure. Alright, so this was the issue. Okay, other than these, oh yeah, now we got 5.8, yeah, I'll check it in a second. The resistor is heating up. Let me see if I can get better focus here. So here's the issue that was here. Other than these the volume controls, you have a volume control here, and this was almost all the way down. That's why we couldn't see anything on the output. So now let's turn it all the way up, This is like master volume, right, for all 6 channels. So if this is turned all the way down, you're not gonna hear anything indeed, regardless of what the position is here. Now let's go to the power calculator, the rapid tables, because who wants to do the calculations? So we have 4 ohms and voltage. So maximum we have 5.87, 16 volts peak to peak. That is likely our supply voltage. 5.8, call it 5.9 at 1 kilohertz. Yeah, oh, the resistor is heating up very nicely. So at 5.9, we have an output power, the real output power, at around 9 watts. This is normal because we're using a Bluetooth input. Bluetooth input will always be limited, meaning you will never get as much power on the output from the Bluetooth device as you would from the regular input. Now I increase the volume on the phone to maximum, and let's see how much power we can get now. Oh, okay, but I don't want to go that high because the resistor is burning. Now it is absolutely burning, and we need to get the scale. Oh, this is the minimum scale. So this is 9 channel 1 position. What is the... Okay, this is 5 volts per division, so I can't go any higher. Let's try again and see. 10, 11, 12, 14, 15. 15. That is going to be a lot. That is 56 watts. Oh, I burned myself. Okay, let's turn it off. So we definitely have output power. The Bluetooth disconnected. We definitely have an output power. 60 watts. So this says that it's 500 watts, and indeed it looks like it's full 500 watts. So about 60 watts per channel, so 120 watts per output times 4. Yeah, that is actually correct. It's very rare with these devices that they actually deliver the power that is stated on the box. Actually, it's rare for the devices that have the output stage that I described and integrated in one chip, or perhaps 2 of them to create 4 outputs. That's what I was expecting in this one. But they will, yeah, they are advertised as 200 watts, but in reality they deliver 15-20 watts per speaker, so nowhere near what is expected. So let us check the outputs. So on the resistor, it's obviously gonna work, and on the beautiful sine wave, it's obviously gonna work. Damn, that heated up, because this allows only 10 watts. You won't be able to see, but this is 10-watt resistor, so it's not exactly for load testing. But on the resistor, there's always going to be a nice signal, even if the amplifier has issues. So the final test that confirms whether this works or not is to connect inductive load. That is the speaker. Okay. Yeah, the speakers sound awful because I fried them. You can see that it completely detached over here. Yeah, I pushed like 80 watts through these speakers, so yeah, I don't know what the rated power for these speakers is, but I would expect maybe 10 watts. So pushing like 80 for them definitely fried them up. Treble to minimum and bass to maximum. Now bass goes away and full treble.
White, and probably he wants that gray area. He wants to give people a pass, but he has to fulfill the mission of the slasher. The mission of the slasher is to pay these people back with a lot.
Okay, the radio is working. This is NPR, and obviously all they're talking about is the assassination attempt. A very weird story. I had no idea. I did not expect that. I did not expect anyone, actually doing that. This is really sad day for democracy. That's not how you solve problems in life. Okay, one thing I cannot test is the microphone inputs because I don't have the proper microphone to test it. The radio is working. The Bluetooth input is working. Now let's test the auxiliary. Yeah, don't do that at home. So what I do, yeah, but don't do that. I like the after I connect it, I like it. If it gives me a shock, I'm not connecting the phone. I fried one phone like that. So this is auxiliary 1. Auxiliary 2. We have 40 degrees on the main heatsink. So this amount of power hasn't even make it sweat, and nothing else is heating here. Okay, so now let's let it run for maybe 15-20 minutes on a little higher power, and then let's analyze the thermal image again to make sure that nothing is gonna overheat, because overheating could also explain this. So the device was turned, I was connected to the power, and something constantly starts heating up and up and up, and after a while the thermal shutdown takes over and it cuts off the output. Alrighty, so it has been a few minutes. It's still playing, it's still working on auxiliary 1, no, auxiliary 2. So what is the diagnosis? What was wrong with it? Well, there has been nothing wrong with it. Either this knob was turned all the way down and went unnoticed, and despite controlling these, there was no sound in the speakers because it was all the way down. It's possible, although I imagine that, you know, when you tested it, you probably turned every knob and pressed every button. The more likely possibility is that one of your speakers is either 2-ohm speaker, which is too low impedance for this device. It's got to be 4 to 8 ohms on the output, or the speaker is faulty. If the speaker is faulty, which basically translates into being a wire, I'm not going to confirm that because it's not healthy for the amplifier, but the output short will be detected, and that's what we have these relays here for. Actually, the relays are there for two reasons. One is to detect once the output short is detected to cut off power, because that's too much power. Second is to protect the speakers. If there is a shorted transistor, the relays should also cut off, so to protect the speakers. However, from my experience with these devices, once there is short on the output, the speaker is going down. The relay is not capable of disconnecting this quickly. And that happened to me once when I just put way too much power on the output, volume all the way to maximum, and I have a little test sound, which is like a lot of bass, so huge amount of power. That caused a short on the transistor, and the speaker just it burned through. It smelled, like completely burned speaker. The wire inside, the coil inside, just completely burned through. So most likely, when you receive it back, check your speakers. You can check the speakers with a regular multimeter. It should show around 4 ohms of continuous resistance. That's not impedance, that's just a series resistance, but it should be around 4 ohms. 4, maybe 8, depending on the speaker. And we can check these just to show you. Yeah, these are 6 ohm speakers. It's showing 5.5, but it's, roughly. So that means the speakers are okay, right? If on the other hand you see this, the speaker is fried, right? So most likely when you check your speakers, one of them will be showing short. That's why the device didn't work. It's too bad I didn't suggest it when the ticket was submitted, because that would have saved us time and a few bucks on bench fee. Not a huge money, but at least now you know that the device is perfectly functional. Oftentimes the speakers will be responsible for all kinds of faults in the amplifier. The better the amplifier, the better it'll react to that, either by shutting down, cutting off output, pretty much these two possibilities. The clicking will always be there, so don't draw too many conclusions from relays clicking. They will always be clicking, whether it's functional or not. Alrighty, nothing left to do but put it back together, bill the customer, and ship it off. Alrighty guys, that was Pyle PTA42BT actual 500 watt amplifier. Very nicely made, works very well with built-in antenna. No Bluetooth antenna though, which is depending on what you want to use it for, but your Bluetooth device needs to be relatively close to it for it to work. But it's a very nice machine. I definitely recommend getting it, and they are very affordable. The Pyle devices, I like them. They're made simply, and they perform as they are supposed to. This will do it. Thank you guys very much for watching. Thank you for your business, Steven. And I shall see you guys in the next one.